Hello friends, today we shall discuss about light, or I will show you some optical experiment. You see, this is our laser. You can see the laser light also here. You see, this is our laser light. You can see the light, ray of light. This is our laser light. You see the laser light. You can see also the path of the laser light. See here, right? And this is the light. You can see, right? Now this is our lens, right? This is a converging lens, or what you say it as concave lens. You see, the light is here. When you keep the lens in between, you see the light is converging to a certain point. You see here, light is converging, right? Here you see, this is the ray of light, right? If you put the lens, the light is converging, that is converging to the focus. You see, you can see the ray of light also. You see this one, right? Now if you take two lights, and if you see that the rays of light will be converging to a fixed point. Here you see, if we take two lights, two LED laser light, and you see the light is converging. You see, when we switch on the light, you see that both the lights are at this position. You see, both the lights are at this position. You can see in a better way, in this way. See, see this one, right? I will put the lens. You see the light is converging. You see here, you can see the converging light. If we give a parallel ray of light, these are parallel rays. When we give parallel rays of light, you see the light is converging to a point. Like say, this is the original point position. If we put the lens, you see this is the converging lens. The lens are converging. That's why this convex lens is also known as converging lens. You see, the points are far apart. You see here, if you keep the lens in between, then you see the points come closer. That means this is converging, right? Here we are giving two parallel rays of light, and that's why this lens is known as converging lens. Here, this lens is converging lens. You see, you can see the rays of light is converging. This is the 2 point, and if we give in between the lens, you see lights come closer to each other. That means they are converging, right? See this one, the light is converging to certain point. Like I said, this is the original position, and if we give this convex lens, the points are coming together. That means they are converging. Right? Now, if we take another lens, this is a concave lens. Now, you see the original position of this light is like this. This is the original position. If we give the concave lens in between these lights, you see the points are diverging. It gives far apart. That means this is a diverging lens. That's why we say the concave lens, or You see here, the lines are diverging from one another. You see, the lights are diverging. This is the point. You see here, and we give this light, this lens, this is the lights are diverging. That means the points are going farther away from one another. Right? You see, you are giving two parallel rays of light, and the rays are diverging from one another. You see this one, right? Or if we take this prism, let's see what happens to this prism. This is the prism. You see, this is our prism. If we give light, you see, the rays of light is bending towards the normal of the prism. See this one? The rays of light is bending towards the normal. Right? You see? The rays of light is bending. See this one? You can see it very clearly. The rays of light is bending towards the normal, and there is a angle of deviation of this prism. We can find the angle of deviation by this method of refraction of light. You see the rays of light? You see the light is bending towards the normal of the prism, and we are getting a angle of deviation of this incident ray in the prism. You see this one? Let's see once again. You can see the rays also. See this one? Right? That means the rays of light is bending towards the normal, and you get the point here. You see this one you see. Right? And you get a beautiful pattern if you put it in this way, like this. You see, there is a beautiful pattern of this prism. There is a beautiful pattern in the prism. See this one? The rays of light is bending towards the normal. You can see the rays of light also. You see here? You can see the rays of light like this is bending towards the normal of the prism, and thus the light is deviated from its original position, and you can find the angle of deviation for this prism. And here you can see this prism is a, and the angle of prism of this prism is 60 degree, because all the sides, you see here, the light is bending towards the normal, right? And we are getting the light here also. And you can see the beautiful pattern in this prism. Beautiful pattern, you see. You see the multiple patterns you can in the prism with this color. Now I will show you the multiple reflection in case of various mirrors. See, this is our mirror. This is a concave mirror, and see what happens to concave mirror. You can see the reflection of light in this mirror also. You see the rays of light you can see. If you increase the angle of incidence, you see the angle of reflection is also increases. You see, you can see the rays of light. Here you can see the rays of light, the incident ray and also the reflected ray through this mirror. You see, one is incident ray, another is reflected ray. And you know that in reflection, the angle of incidence is equal to the angle of reflection. Here you can see the rays of light. Here you can see the path of the light through this one. Right? If you take another mirror, this mirror is a convex mirror. You see, in convex also, convex mirror, you can see that there is reflection of light. See, and here also you find the angle of incidence is equal to the angle of reflection. See, you can see the ray of light. Here also you can see the angle of incidence and the angle of reflection. Right? And if we take plane mirror also, in case of plane mirror also, you will see the here you see this is our plane mirror. In case of plane mirror also, you see that the angle of incidence and angle of reflection is same. Here you can see the path of the rays of light. You see here. Right? And if you take a glass slab, you'll also get the rays of light refracted through the glass slab. You say in the we know the reflection of light that the incident ray, the reflected ray, and the normal all lie the same plane. Not only that, the angle of incidence is also equal to the angle of reflection. You see the rays of light, and if you find the angle of incidence and angle of reflection, you find that the angle of incidence is same as that of the angle of reflection. See the rays of light were clearly visible. The rays of light is clearly visible, and you see this is the incident ray and that is the reflected ray. And the angle of incidence equal to the angle of reflection. See this one where clearly it is clearly visible. You see these rays of light you can see here. Right? Now I'll show you what happens in case of glass slab. You see this is our glass slab and show you the glass slab and what happens to the glass slab. See this is the glass slab, and if we give this light, you see there is a refraction through this glass slab. You see that there is a bending of light and there is a lateral dispersion in case of glass prism. You see this one, and you can see the beautiful pattern also in glass prism. This is the beautiful pattern you can see in the glass prism. In the glass slab, this is the glass slab, and you can see the beautiful pattern formed in the glass slab. You see. Now, if we give light here at this surface, you see the rays of light is bending, and there you can see you see this is the rays of light passing through this glass slab, and there is reflection in this glass slab. If we put the light normal to this glass slab, it will see that the rays of light passing without bending. You see here that the rays of light is passing without. If we give this light perpendicular, then the rays of light will not bend, it will pass through in a straight line. You see, you can see here. And if you bend this one, incident ray, then it is refracted. You see, the light is bending and there is a refraction. You see here, if you put this glass slab in this way and put the lights on, you see there is a, you can see there is a light here also. You see, that is a light. The rays of light is bending, and we can see there is two laws of refraction. The first law of refraction says that the incident ray, the refracted ray, and the normal all lie in the same plane. And the second part is that the sine of angle of incidence and the sine of angle of reflection, the sine of angle of incidence, the ratio of sine of angle of incidence and the angle of refraction is always constant. That is sin I by sin r is equal to constant. Here you see light passing through this glass slab. The light is refracted according to the Snell's law. The second law of refraction is also known as Snell's law. You can also see the beautiful pattern in a glass slab. See, this is the beautiful pattern you can see in a glass slab. Right? You can see the beautiful pattern in this glass slab. Here you see, this is the glass slab. I can see the incident ray, the refracted ray, and there is a lateral displacement also in this glass slab, lateral displacement of the incident ray. You can see the beautiful pattern in a glass slab. This is the beautiful pattern you can see in a glass slab. You see, you can see the rays of light very clearly. Can you see the rays of light? See here, you can see the rays of light passing through this glass slab, and that is refracted according to Snell's law. And the first law of refraction is the incident ray, the refracted ray, and the normal all lie in the same plane. And the second law of refraction is the sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is always constant, and that is Snell's law. Right? I will show you some experiments on these optical instruments with this laser light. And if you pass this laser light through the glass slab normally, then the ray of light is not refracted, but it passes through the this slab perpendicularly, and it will not bend. The ray of light will not bend in this glass slab if the incident angle of incidence is 90 degree. It will not bend. Right? Now I've shown you the different patterns formed in case of glass slab, in case of prism, in case of mirror. Now we can show you the different multiple reflection in case of prism. In case of, you see, you can see the multiple reflection in case of mirrors. You see, there is multiple reflection here. See here, multiple reflection, you can see it very clearly that there is multiple reflection, and you can see the rays of light also. You can see the beautiful pattern and multiple reflection in different types of mirrors, that is plane mirror, concave mirror and convex mirror. Now, we have shown you the laws of reflection and laws of refraction. The laws of reflection, there are two laws of reflection. The first law of reflection is the incident ray, the reflected ray, and the normal all lie in the same plane, and the angle of incidence is equal to the angle of reflection. But in case of refraction, there are two laws of reflection. The incident ray, the refracted ray, and the normal all lie in the same plane. And the second law is also called as Snell's law. That is, the ratio of sine of angle of incidence to the angle of refraction is always constant. That is Snell's law. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.